We have a pretty good number now, so we'll go ahead and get started. This is Sybil Charvel. I'm the project PI at Colorado State University. Thank you everyone for joining. We're really excited for this opportunity to provide some update and opportunity for some of our participants to ask some questions and learn more about the project and what we're doing. So thank you all for attending today. We also have here the volunteer coordinator, Alicia Kroll, and I'm going to just have her take a minute to introduce herself.
Hi, everybody. It's Alicia. Thanks for joining us. I'm going to be assisting Sybil this evening with answering questions that you may have. So if you do have questions, you can type those into the questions box. We're likely going to hold off on answering those until the end of the presentation. But if there's something related to clarification on any of the content and any of the slides, we can interrupt Sybil as we go through that. But we'll likely take most of the questions at the end. So feel free, though, during the presentation to go ahead and enter those questions, even if we don't get to them until the end of the presentation. So thanks again for joining us.
Okay, so this is the Off the Roof project, and thank you not only for joining today, but for those of you that are study participants, thank you so much for your participation in the study. I know that this is a really time-consuming study, and we really appreciate the time and effort that all of you guys have been putting into this project to make it successful. Okay, so what I'm going to go through today is go through the background and objectives, make sure everyone understands the motivation for our study and why we decided to do it, and then talk about the locations for participants and some of the roof attributes, several challenges that we've come across through the study, which I'm sure some of you are aware of or have experienced to some degree, and talk about how we've worked to overcome some of those or still working to overcome some of those challenges, and also talk about some of the data that we've been collecting on the samples that you all have been collecting at your homes. Okay, so starting off, there's a lot of different source waters that can be used at a building scale. Most of the participants in this study are households, are residential participants, and they volunteered their household to collect samples. We do have at least one school participating, but we can also collect these different water sources at a larger building scale. So there's many different water sources that can be used at the building scale, from residential up to multi-residential or commercial buildings. We have black water, which would be toilet water and kitchen water. There's gray water that's generated from showers and laundry. Then roof runoff, which is what this project is about. And then there's also sometimes local storm water from other runoff from rain from other sources that can be used as well. So these are all sources that we can collect on site and make use of. And again, this project really focuses on the roof runoff component, and we'll talk about why we were so interested in that in a little bit. So to guide the use of these different water sources, there's all sorts of different water quality for these sources. So there's different chemical constituents in all of these different water sources, and there's different biological constituents that are the pathogens that can result in illness with exposure. So what we consider right now is fit for purpose treatment of water, which means to treat water to an appropriate quality for the end use. So if you're going to be using a water for spray irrigation, there's some exposure associated with that, versus if you're flushing a toilet, there's a different exposure to that water. And then obviously when you're drinking water, there's a very high exposure to that water. So we think about both the source water quality and the end use when we think about levels of treatment that are needed for all of those different water sources. So just kind of backing up to this slide, all of these different water sources have different quality, and then they can be used for different purposes, and the treatment can be different based on that source water quality and whatever purpose the water would be used for ultimately. So we try to think about these treatment levels based on human health risk. And we use what we call quantitative microbial risk assessment, or QMRA, to set log reduction targets for pathogens or bacteria, virus, and protozoa that could make people become ill in the water. So we start by characterizing pathogens in the source water. Then we determine the exposure based on end use. So like I was saying, an exposure of drinking water compared to toilet flushing is quite different. So we don't need to treat as much to flush a toilet as we do to drink water. Then we select some acceptable level of risk, and we set what's called a log reduction target, which is how much of that pathogen has to be removed. I don't want to get into the details of this table, but this really drives home the point of why we're doing this study. So there's all of these different end uses on the left here, source waters on the left here, and end uses as well. So for example, we have domestic wastewater, gray water, and then you can see tabbed in, there's irrigation or indoor use. And then we have these log reduction targets. So that's how much of either virus, protozoa, or bacteria would have to be removed from that water to make it safe for that particular end use. And this was a study conducted about a year or two ago that I was the chair for, where we came up with these recommended treatment targets for different source water end use combinations. But when we look at roof runoff water, that is an area where there was very limited data to support how much treatment is needed. So you can see no data under parasitic protozoa. Enteric virus was not applicable. Human viruses are typically not in roof runoff, but also bacteria. We provided a log reduction target, but we're not particularly confident about that value. There wasn't very much data to support that either. So that's ultimately the driver for the study, is to fill in these points where there's not enough data to support how much treatment is needed for roof runoff to use it for different end uses. So how can we characterize microbial quality of roof runoff, which is what we really need to do in order to inform how much treatment could be needed? We really need this very extensive data set that accounts for different climates, different roof materials, different regions of the country. And so this looks like the perfect opportunity for citizen science to be applied, because it enables a large number of samples to be collected from these very dispersed locations. And we are also really excited that it engages the public to become more educated on use of some of these non-traditional water sources and local water sources that can really help meet supplies in demand-limited regions, and really kind of help people understand benefits and risks associated with these different alternative water sources. So then the objective of this project is to engage citizens in roof runoff sampling that informs the public on use of alternative water sources, while also collecting data on microbial water quality to better inform treatment targets. So at this point, we're really not highly confident with the amount of treatment that's needed for roof runoff to use for different purposes. So this study is to help provide that guidance. So that's ultimately the data that all of you are helping us to collect. That data is there to help to inform treatment standards. So basically what's happening, as most of you probably know, is that we're having participants collect samples from their homes or schools from roof runoff, collect those in barrels, and then collect samples into bottles, and then we process those samples in the lab to measure both chemical and microbial quality of those samples to hopefully inform these treatment standards later. So to get into a little bit to our team, today we have here myself, Sybil Charvel, And then we also have Alicia Kroll, who you've been communicating with likely quite a bit. She's been managing participant communication and really taking care of making sure we have this liaison between the participants and the scientists that are engaged, so that we can have that good line of communication and address any sorts of issues that might come up, as well as inform participants of what's needed for the study. We also have, in each of our study cities, we have PIs that are the scientists for the project that some of you may have likely interacted with. So we have Dr. Tom Meister in Tucson at University of Arizona. We have Dr. Claire Welty at University of Baltimore, and Mike Sukup at Florida International University in Miami. So those are kind of the lead PIs that help to manage this project in each of our study cities. We are also collaborating quite a bit with the US EPA, so that's the Environmental Protection Agency. They are helping to analyze microbial quality in our samples. So we have a group led by Jay Garland that's leading all of that. And then we also have an advisory committee that is helping to advise the project. And I want to go back here to the bottom left one. In addition to Alicia Kroll, that's helping to manage the citizen science component of the project and participant outreach, we also have Dr. Greg Newman here at Colorado State University, who has been developing the SitSci platform that many of you have been using to enter information about your sample collection. Okay, so going back to now where the households are located and where we've selected participants, and we have, again, a project PI in each of these various cities. So there's Denver is actually Fort Collins is where the study's really being conducted. That's just kind of the front range of Colorado, and all of our study locations are really in Fort Collins, which is north of Denver a little bit. We have Tucson, Arizona, where again we have Tom Meister, and then Miami, Florida with Mike Sukup, and then Baltimore, Maryland with Claire Welty. So there are 7 selected locations or households in each of these study cities. So a total of 28 participants in the study that are helping us to collect samples from their residence or school. Okay, so this gives a little bit of information about the types of roofs that we selected. So we really tried to select households or roofs based on their geographical location. So we had the 7 in each study city, but then we were kind of looking to have those dispersed throughout the city. We were particularly interested in urban and suburban areas, so we were trying to select households or roofs that were located in areas that would be characterized as more of an urban area. And then we wanted to also have a variety of different types of roofs. So these are the types of roofs that are included in the study. We just have one metal roof in Miami. We have asphalt shingles are by far the most common roof type that we see, and almost all of our participants in Fort Collins, except for one, have asphalt shingles. Rolled roof is a kind of roof that that also is kind of like a shingle, but more of a single slate of asphalt shingles. And then we have slate and tile, which we have some in Miami and Baltimore, and then one concrete roof in Fort Collins. So we try to do our best to get a variety of roofs, and we were hoping to have more than one, for example, metal roof or concrete roof, but it just wasn't feasible with the participants that we had to select from and some of the other considerations in the project. Okay, so as you guys probably know, the way the study is set up is that participants collect the samples. So participants have set up their rain barrels at their homes or schools, and put all of those pieces together and have them ready for sample collection, and then work to help us to collect the samples. And then you guys have been putting those into a fridge. And basically we have 2 samples that you guys typically collect, which is 10 gallons that we filter at our university locations in each of our study cities, and then 1 liter samples that are shipped to Colorado State University for analysis of some chemical parameters. This is the citsci.org website. I think most of you hopefully have become familiar with this website. This is where participants can enter in the information on their sample collection. This data, as I'll show later, is really useful for us in order to help us interpret the water quality data that we get when we analyze the sample. So this is kind of asking you guys to fill out a lot of information about, did you see leaves? And participants can also take pictures and upload those. How much do you see animals? All of these kinds of things, and rainfall depth. We have gauges out at each of the homes, volume of water in the barrel. All of these are really critical data points for us to consider as we analyze all of our data. So we really appreciate participants filling out these forms when your samples are collected. And again, Greg Newman at Colorado State University has been the one to help develop this platform. And interesting on the site, if you haven't browsed around, there's a whole lot of citizen science projects there that you can look at and see what kind of data have been collected. So this serves as a national platform for citizen science projects and has some really interesting other projects that are on there as well. Okay, so I don't want to get into too much detail here about the analysis methods, but I just kind of want to note what we're measuring and where, just for everyone to know a little bit about that. There's the biological parameters, and we have what's called indicator organisms. Those are organisms that serve as indicators for true pathogens. That's an analysis we do here in our Colorado State University labs, but the pathogens are more complex analysis, and the United States Environmental Protection Agency labs are set up very well to do that, and they're taking care of actually measuring particular species of bacteria and protozoa that support this study. And then we need to know the chemical quality of the water as well. Some of you guys have hopefully started to look at some of our results. I'll be sharing some of those today as well and can answer more questions. But we've created a document online that's available through the citsci.org website where you can actually view results from the study cities to date and also get descriptions of what all these chemical analyses mean and what typical ranges would be for them and what you should expect and what they also mean in terms of the safety of the water. Okay, so I did want to kind of just go through some of the things that we've encountered and learned during this project and how we've been working to overcome some of those things. So our first thing that we realized that we really try to have all of the processing of these samples be within 72 hours of their collection. We've realized that constraint is very difficult to handle. So that's been something that's really served as a kind of a constraint and rushed us sometimes and kind of rushed us into some things that were potentially problems in the beginning. This first problem we realized not only until we collected or had a rainfall event in Fort Collins where we don't get very many rainfall events, and we were waiting and waiting for our spring event, and it happened to come on a Wednesday and get done on a Thursday evening. And this was a problem because we can't send our samples to US EPA over the weekend. So we had to work to develop some protocols to either not have samples collected during that time period, or we've worked also with EPA to coordinate with them ahead of time to try to have someone that can come in over the weekend to be able to get those shipments and process samples. So we've had to develop some protocols related to timing of samples and making sure we have a really good line of communication about those. One of our first sample events, the participants just couldn't get samples collected in time, and we realized that we were placing some really unrealistic constraints onto our participants to collect samples really quickly after an event happens. And you guys all have work schedules, school schedules, things to take care of during the day, and it's not always possible to go and spend an hour collecting samples right after the event happens. So we realized we just need to allow for more time for sample collection from participants and consider people's work hours. I talked a little bit already about the holding time of 72 hours. That's something that we've just had to relax and really just make sure we document the time of each of our chain of events. So for example, we try to document when the sampling event ends, so when the rainfall event ends, when we actually pick up samples from homeowners. If we have any information on when they actually collected the samples, that's helpful. And we calculate also when we ship those as well. And just really documenting all of those things so that we can be careful to look at those as we analyze the data as well. We had a lot of problems with the rain gauges. A lot of times homeowners are moving those around throughout their yards, which is completely understandable if maybe they're doing landscape or whatever. Those we're really trying to work to correlate how much water we collect in a particular event with the rainfall depth from that event. So we're also, in addition to understanding microbial quality, we're really interested in understanding how much of the water that falls onto a roof actually makes it into the barrel. So that's something we're really interested in, and a lot of times our rain samples don't get collected. So we're trying to just remind participants about that. I'm sure some of you've gotten those reminders in your email or text messages about making sure your rain gauge is in a place where we can actually collect rain and it's not sitting under a tree. Most important thing is advanced notifications are important. Informing our participants when an event's going to happen well ahead of time, having really good lines of communication with all of our students that are helping to go out and collect those samples and process them, having a line of communication with the US EPA to process those samples. All of these lines of communication are really critical in this project. This is an example of some of the data that we've gotten from the citsci.org website. And we see here a couple examples where people have recorded the rainfall depth. This was from a sampling event that was in Fort Collins, Colorado, and most people measured, so there's 1.67 inches recorded at one home and then 2 inches at two of the other homes. And then we have measurements of how much volume was collected in the barrels, and then several observations as well. So we've been pretty successful with getting a lot of this information from you guys. And again, we really appreciate your taking the time not only to collect these samples, but to provide us with these kinds of observations that help us to analyze the data. As we get more and more data coming in, this information will become more and more useful for us to interpret the water quality. And this is actually really points to how important this is. So this is a picture of some of the samples that were collected in Fort Collins, and you can see there's just a tremendous variability in how these samples look. So this one that's the fifth over from the right looks pretty clear, whereas the one right next to that on the far right looks pretty dirty. You can see some debris that's settled at the bottom. So having recordings of, oh, yes, there was a lot of leaf droppings or whatever on my roof before that event, these kind of things really help us to understand why these samples have the characteristics that they do. And we do find that they're extremely variable. So they don't look just variable in terms of how they look, but they're also with measuring the water quality of these particular samples, there was a lot of variability in particularly chemical water quality as well. So that's another really important aspect. Okay, so now we can move a little bit into some of our results, which I'll help to explain. We've been able to collect samples. We got one spring sample in Fort Collins, and then the other cities were not able to collect spring samples, but we have summer samples in the other cities. So Fort Collins, Tucson, Baltimore, Miami, those were all collected between August 17th and September 7th and kind of count as our summer samples. We don't actually have the data yet from EPA on the true pathogen concentrations in these waters, but we do have data from our labs on the indicator organisms, which again can serve as an indicator for how many true pathogens you'd expect to see in the water. But also important to note is that these can come from animals. So things like E. coli, total coliform, those often come from animal droppings, whereas the true pathogens that we're measuring also can come from animals, but they do actually result in human illness. So many of the indicator organisms that we see in roof runoff are actually related to animal droppings and wouldn't result in a human risk. So that's what we're trying to kind of understand. Unfortunately, we don't have the data yet to really discuss that type of correlation. But these samples, the indicator organisms are at least something that's useful for us to understand. So important to note, so total coliforms they're typically the highest. They measure multiple sources of bacteria that could contribute from fecal contamination, whereas E. coli and enterococcus are both more specific. So the total coliforms are in blue diamonds here, and the enterococcus are in green circles, and the E. coli are the orange squares. And so we can see that E. coli is the lowest in our samples, which is what we would expect. So these lines here on each data point basically represent the variability. So these orange lines going up and down say the samples on average varied from, this low level to this high level. So we do see variability in these, but really amongst our different samples in different cities, we're seeing pretty consistent concentrations of each E. coli, enterococcus, and total coliform. I just popped up this thing at the top right here. This is just some information to kind of help relate the interpretation of this data. So in reclaimed water use for irrigation, so that's taking treated wastewater and using it for irrigation. California has a standard that water should have total coliforms of 2.2 per 100 mils. You can see that would correlate to a log 10 measurement of 0.34. So we report these concentrations in terms of logs because that's a typical way to represent these. But 0.34 logs would be way down on the bottom, the first quadrant, or first between 0 and 0.5 on the y-axis. So you can see that our total coliforms are far in exceedance of that California standard for reclaimed water irrigation. Texas has a much more lenient standard. They have 20 E. coli are allowed per 100 mils, which would correlate to about 1.3 logs. So again, 1.3 on that y-axis, which you can see some of our samples are falling below that and some of them above. I think that just gives some perspective to understand kind of the microbial quality of these roof runoff samples. But I'd also like to note and repeat again that these can come from animal sources that don't pose a human risk. So the data that we're going to get from US EPA later on in the study is going to be much more informative to help us really understand what the human risk level is. Okay, so now moving on to some of the chemical water quality, we have turbidity here. Turbidity basically measures cloudiness. And I'm just going to take a second and go back to this to explain turbidity. So looking at these, that sample on the far right would have a really high turbidity, and then the sample to the left of that would have a much lower turbidity than that. So turbidity really, again, measures that cloudiness of the water, and it's often related to pathogen concentrations and microbial quality. So these are measurements of turbidity. We measure those in units called NTUs. And just to kind of frame these in terms of a meaningful value, generally turbidity is supposed to be less than about 5 NTUs for reclaimed water for irrigation. So we have some of our samples falling into that standard, but again, many of them not. And now we have organic content. So those leaves and debris that are up on roofs all can leach out organic matter that's measured in the roof runoff, and that's fine to have organic content in roof runoff if we're using it for maybe irrigation or toilet flushing. It's not necessarily a problem. It tells us though that organic matter does serve as a food source for pathogens or bacteria or viruses to grow off of and to consume and grow. So we do want to track that to help understand and interpret our data. We have values here ranging on average from down below 50 milligrams for maybe like 25 milligrams per liter up to above 250 milligrams per liter. Really high variability. Remember, these lines you're looking at again off of these data points represent standard deviation, which tells us how much variability there was in our data, particularly this data collected on August 17th in 4 columns. So the second data point from the left that's shown in this graph, you can see really high variability, a lot less than a lot of our other samples. And some of those are those ones you looked at that really just had a whole lot of debris in them. And some of our other cities just didn't have as much debris in the samples that they had collected. Just to kind of frame this a little bit, like I said, see, chemical oxygen demand is a measure of organic matter. It doesn't pose a risk on its own, but just to kind of frame this in a way that you can understand, treated wastewater that comes from a municipal wastewater facility typically contains less than about 30 milligrams per liter of organic matter measured as COD. So that just kind of helps to frame these results a little bit, I think. Okay, so some early findings from this work so far are the time input for participants and students collecting and processing samples really turned out to be more than we expected. I said in the beginning, we really appreciate all of your time input to set up these systems and collect these samples to support the study. Has been, during our sampling events, a little bit more consuming than what we had originally expected. Likewise, processing all of these samples at one time has been very challenging. When we first envisioned this study, we were thinking of including something like 8 to 10 cities and trying to have 20 participants per each of those cities. And something we've learned from this is that it would be virtually impossible for us to process all of those samples if they all came in at the same time in a way that would support our quality control measures that we have in place for the study. So that's kind of something that we're considering and moving forward and how we want to expand potentially this study. Roof runoff quality we've figured out is highly variable. Pathogen indicators, organisms are present, but we're still waiting on the data from US EPA to tell us about true pathogens and inform these treatment targets like we talked about in the beginning of the presentation. Moving forward, winter sampling events will happen in all cities. We also have, I didn't mention, I'll let me just go back to some of this data really quickly. I did not mention that we have these fall sample or summer samples reported. We've also collected fall samples in each of the 4 study cities. However, just haven't gotten that data into all of our systems yet. So that should be up and coming, and we'll notify all of the participants as soon as that new data becomes available, which should really happen in the next week, I would guess, because we just finished processing them all in the last week. Okay, so now we've done a summer and fall sampling. Winter sampling events will take place in all of our study cities, and we'll be making more and more data available on the citsci.org website, and we work to inform Alicia every time we get new data up there so that she can let all of you know if you're interested in looking at some of the data. We need to assess a path forward for how we might expand the study, and in the context of understanding the data that we've brought in so far, what would be most useful in terms of expanding the study and thinking about the time it takes to process all of these samples and what we can actually physically do. So that's something that we're considering now. And ultimately, like we talked about in the beginning, we're wanting to take this collected data and make use of it to inform treatment targets for roof runoff, and that would ensure safe use of roof runoff for different purposes like spray irrigating, toilet flushing, or potentially even making use of that water for drinking. So we really want to inform what's the appropriate treatment of the water for those different purposes so that we can ensure human health also while minimizing treatment expenses and energy required, so not over-treating the water, but really thinking about this fit-for-purpose treatment of roof runoff based on the end use. Okay, so with that, we can go ahead and take questions if any of those have come in.
Hey, Sybil, thanks so much. We have not had any questions come in yet from, so Claire, she just said, this is Claire, I have some questions. Claire, if you have your mic connected, I think that we can unmute you and you can actually speak through the microphone. Let me try that real quick. Okay, see if you can speak now, Claire.
Okay, Great. Here I am. I'm sorry, I came home from an event just to tune in at 8, and then I got distracted with something else, so I didn't tune in until like 8:25. So just a couple things. One thing I think, so just for the whole group's information, I think maybe we're the only city where I have personally been collecting the samples just because I don't have any personnel right now. So the QA/QC is just top drawer here. But the comment I have is, I think that one important variable, maybe it should be, being a hydrologist, the antecedent conditions. And it's interesting because I think in both cases where we've collected our summer and fall events, we probably had a period of about 10 days of no significant rain. And I would expect the antecedent conditions to affect the water quality, because you would think if there's more gunk buildup during a period of no rain, that might affect the water quality. So what I would suggest is that in the future, one thing we might want to consider is noting down, like, well, when was the last time it rained? Because that may be an important variable. So just FYI, I thought that was something to consider. And also, I was wondering, Sybil, did you guys sort these yet by roof type at all?
Yeah, so I'll answer your second question first, which is we really don't have enough data yet until we really need to have the full data set of at least 3 seasons before we can start running statistical analyses on roof types or locations. There's just not enough statistical power in our data. The variability really, to me though, Claire, just kind of as just observationally, it really depends, I think, a lot on roof location, proximity to things like trees and probably animals on the roof and things like that. more so than the type of roof, but that's just kind of my gut from what I've seen so far. We really need to get the full data set to have enough samples to make some of those statistical correlations, and we'll be looking at the region, as well as, like you mentioned, the duration from events. So we'll at least use rain gauges, local rain gauges, to try and track the last event for these cities. And so we'll use that as a variable, and also so region, roof type, all of those different things to assess, and season, to try to find correlations in the data that we see. I do think it's really important what you brought up with respect to when we collect these samples and the frequency or the duration from the last rainfall event. So for example, I've gone back on my screen to show these samples. I said that we were waiting and waiting and waiting for a sample in the spring in Fort Collins, and finally on May 29th we got that, but it had been at least 8, 10, maybe 12 weeks before we had any rain that resulted in substantial runoff prior to this event. And then there was a lot of pollen and things that were depositing on roofs by this time. So that has a lot of impact, and I think that definitely needs to be included as a variable. We'll do our best. I think we could actually maybe even add something for participants to just kind of note maybe when they may have observed rainfall prior to that, but we can at least use some of the local rain gauges to look at that as well.
Yeah, thanks, Claire. We haven't had any additional questions come in, Sybil, but I did want to let all the volunteers know that are online now, and also those that might be listening to the recording later. If you do think of additional questions after we get off today, please send those to me, and we'll compile all of them with responses from the research team, and we'll make those available. We might upload them to the citsci.org site, but also send them out to everyone via email. So if you don't have a question right now, but something pops up later, then definitely send those our direction.
And I don't think that we mentioned at the beginning, Alicia, that I think it's been informed by some people, but regardless, we are recording this. So if you'd like to go back and watch a portion of it at some point, that'll be available on our website, and Alicia will be sending out communications with respect to how to access that to all of those who weren't able to participate today as well. So you can be looking for that.
And I also want to add, giving a little bit more time in case some folks do have additional questions, but Sybil mentioned it as she was going through her presentation, that we're learning a lot with this being a pilot study. We're learning a lot about what works and what doesn't work. And so the feedback that we receive from all of you on any sort of complications you're having or barriers in your data collection, definitely keep all of that feedback coming to us, because we will compile that, and that will help us inform, hopefully being able to broaden the study in the future. Still no additional questions, Sybil. I don't know if we want to wait another minute or if we feel we should end.
I think we can go ahead and close, and just certainly everyone, please feel free to circle back with us with additional questions as those may arise. We'd be happy to take anything that comes up. So thank you again, everyone, for participating tonight. Thank you for all the effort that PIs have put into this project, and participants. We're really appreciative of all of the people that it takes to make this study happen, which is quite a lot of people. So thank you, everyone, for your contributions.